Pre-Calc. Today we're starting trigonometry part of this course. It's Unit 5, and we're going to first look at sections 5.1 and 6.1 in your textbook. So again, this is the beginning of the trigonometry portion of this class. Trigonometry is the study of angles and sides in triangles. I always say TRIG for short, and you can do the same. And so we're going to need to do a little bit of review. For the first part, I want you to write angle, and we need to know the sides of the angle. So first of all, it's a geometric figure that's formed by two rays with a common vertex. Vertex in this picture is where those two rays meet. And so I'm highlighting that in red. The initial side of an angle is the position. I want you to imagine this graph on graph paper. It's always on the x-axis. It's called the initial side. This is where the angle begins, and then when it opens up in this direction, it forms the rest of the angle. The second ray of this angle is called the terminal side. So we need to know the difference between those two words. When rays are rotated, rotation, remember, means turn in a counterclockwise direction, the angle formed is positive. So when I have the initial side drawn on top of the x-axis, pointing towards the first quadrant, and I swing the angle open, I rotate it counterclockwise, then this direction will form a positive angle, depending on where the terminal side lands. When rays are rotated in a clockwise direction, the angle formed will become a negative. So we also can take this initial side, swing the angle open underneath, like imagine in the fourth quadrant, and any angle that moves in a clockwise direction is a negative answer. Remember from the past that there's always 360 degrees in a complete rotation. So looking at the first example that I've drawn, notice that this angle has the initial side, again on top of the x-axis, and the terminal side, I'm highlighting in green right now, and it is in the second quadrant. The place where they meet is called the vertex. Please notice that as I open or swing this angle towards the left, counterclockwise, it forms a positive angle. So we're going to, in our notes, call this 120 degrees. Alright, notice picture 2. In diagram 2, the initial side is again on top of the x-axis. The terminal side this time lands in the fourth quadrant. Notice the arrow. I am opening this angle up clockwise, and so this angle would be a negative. So we're going to substitute in like a negative 30 here. Just a quick example. So 120 for the number 1 and negative 30 for question 2. Alright, so let's practice some more examples. This says give angle measures for the following rotations. So 2 rotations counterclockwise. I want you to imagine that we are drawing a picture this way. We're starting here, and we're going to rotate 1 complete rotation and then 2 complete rotations. So I'm going to land right there. Since there's 360 degrees in one circle, and I'm going around twice, and I'm going in this direction, we know that the answer is positive, so all you have to do is take 2, multiply it by the positive 360 to get 720. Okay, really easy. Example 2. We have to give the angle measure for 3 rotations clockwise. So again, I want you to picture this diagram. I'm starting with the initial side here. Follow the arrow. I'm going all the way around. When I get back to the initial side, I'm now at negative 360. I'm going to wrap around rotation 2 and complete the rotation there. Okay, but the fast way to do that is to take 3 Remember, clockwise means negative, so just multiply 3 times negative 360. You need to know how to do it visually, though, as well. So that's negative 1080 degrees. Okay, question 3. We have 6.5 degrees rotation. Notice that in number 3, I did not use the word or didn't tell you the direction. Anytime that the textbook does this, make sure that you keep in mind that you're to assume it is counterclockwise. So anytime they do not tell you, it is counterclockwise. You're going to write 6.5, and you're going to multiply that by 360 degrees. Alright, so we'll do that now and see what we come up with. So we got 6.5 times 360. That's going to end up being 2,340 for that particular answer. Alright, moving along. Next big learning target is we need to make sure we understand the word coterminal. Two angles are coterminal angles if they have the same terminal side. So please notice in this picture, first off, that it's a 45-degree angle. The initial side is on top of the x-axis. The terminal side is the ray that I'm highlighting in red. It has landed in the first quadrant. It has been opened up counterclockwise, forcing it to be a positive answer. We're looking for what is coterminal with the given angle. Again, coterminal angles are angles that have the same terminal side. A really good way to do this is to picture starting on the same initial side, going all the way around, complete circle, and then landing where the terminal side is. So if I give you 45 degrees, you need to picture this in your head. That's what coterminal means. But you can actually remember that the rotation is 360, so all you need to do is add 360 to 45. If you do that, then you'll get another coterminal answer. So 45 plus 360 gives me 405 degrees. That's a good answer for that one. Now, if you have to give more than one answer, then you just can keep the rotation moving. You can continue this, go all the way around again. As long as you land on the same terminal side, then it's coterminal. So if you go around twice, then that's 2 complete rotations. 360 times 2 is 720. So you can take the given angle, which was 45, and add 720 to it. And you can keep this kind of pattern moving. You can come up with an infinite number of answers here, just as long as you understand how to get there. When they ask you to give all answers, because that is possible, give all coterminal angles for 45 degrees, then what you're going to need to do is start with the given angle, 45, and instead of giving like specific answers like I did here, if they say give me all coterminal angles, you're going to give an expression for that. So it's going to be 45 degrees plus 360, again because it's in one rotation, times, and then they like to use the letter K, and K stands for number of rotations. That's what the K stands for. Alright, so two angles are coterminal if they had the same terminal side, and you can give specific answers or you can give the general answer, which is an expression containing a variable. You can pick any letter you want, but like I said, often they use K. Sometimes I've seen they can use N for that as well. Alright, so far we've looked at the word trigonometry, study of angles and sides and triangles. We've looked at an angle, the difference between initial side and terminal side. Moving or opening up the angle in different directions creates different answers. If it's counterclockwise, it'll be a positive. If it's a clockwise motion, the angle will always be negative answer. And just remember there's 360 degrees in one circle rotation. And then we've looked at the word coterminal, and again that means they have the same terminal side. Next is degree. The word degree is most common unit used for measuring angles. And I know you've had that in geometry and you've had that in middle school as well. So degree is the most commonly used unit in measuring angles. 1 degree is equal to 1/60th of the measure of an angle in an equilateral triangle. So, for example, looking at my picture right now, if it's an equilateral triangle, that means that all the sides are the same length. If it's a true equilateral triangle, then it's also equiangular. All the angles are the same measure. Since we know from geometry that all three angles add up to 180, that means each of these are 60 degrees apiece. A degree, 1 degree, is 1/60th of that angle. So imagine, and this is very difficult to show, but imagine that you were able to draw 60 rays coming out from that one angle. They would be super close and so small to see, it would be very hard to see. But each one of those is 1 degree. So that's where that degree comes from. Okay, so degrees are all related to the measures of angles in an equilateral triangle. Degrees are divided and can be divided up into 60 equal parts, and those are called minutes. So degrees can be divided up into minutes, and each minute can be divided up into 60 equal parts called seconds. You are used to just measuring angles with degrees up until now. And so what we're going to learn today is how do we take an angle and divide it into degrees and minutes and seconds. And this is commonly used in navigation, Google Maps. You can find any location and they'll usually give you 3 numbers. So for example, you might look up a location and see 42 degrees, then you see a number 15, and then maybe a 32. It's more specific. So navigation, the Navy, all kinds of people use this concept to pinpoint a specific location. It's more specific than just degrees. Degrees, minutes, seconds. Alright, next concept is taking what I have just gone over and learning how to convert. So these next 2 examples are changing angles to degrees, minutes, and seconds. Example 1, we have 329.125 degrees. 329.125 degrees. Your first thing I need you to show is the whole number part. That's 329. You'll grab the whole number and you'll put the degree mark on it. Next, we're focused on how do we get the minutes. Recall from the last slide that degrees are divided up into 60 equal parts called minutes. So what you'll have to do is now take the decimal part of this problem, which is here, and that would be like 0.125, and you are going to multiply that by how many minutes are in a degree. And we just learned there are 60. Okay, so you'll bring the whole number down, you'll add to that whatever the decimal part is, you'll multiply that by 60. So on your calculator, we're doing that now. The next step, you'll drop your 329 degrees down, and then plus, and go ahead and find the product of those 2 values, and you get 7.5. Now what usually happens is, usually there is a decimal here, but the whole number part of the decimal is actually the minutes. Okay, so next step, you'll bring down your whole number, 329 degrees. You'll take the 7 and you'll use it as the minute, and there's like one little tick mark above the 7 that illustrates minutes. And then notice the highlighted part. I'm getting ready to highlight right now. This is the leftover piece. And that's how you're going to calculate the seconds in this problem. You're going to drop down a plus sign. You're going to take the 0.5. Since there are 60 seconds in a minute, you're going to multiply that by 60. Okay? Again, notice the steps I'm showing, so I need you to do the exact same thing. We got 329 degrees, we've got 7 minutes, and then you are going to take 0.5 of 60, which is half of 60, and that's going to be 30. So we're going to just drop our answer down. And remember seconds, in order to show that, you have to show me 2 tick marks above. And that is our first example on how do we change from just a degree answer to a degree minute second answer. Alright, so we'll try that again. One more on this. Let's go with 15.735 degrees. First, again, you take the whole number part. That's the easy part. You drop it down. That's automatically the degree part of your answer. Next, you take the decimal part. I'm underlining in green. You drop your plus sign down. You'll take the 0. Or you can just write 0.735 if you want. And you're going to multiply that by 60, again, because there's 60 minutes in 1 degree. Okay, next step, drop your 15 degrees down. And you're going to calculate 0.735 times 60. And on your calculator, you should see a 44.1 right now. Okay, so I do want you to record what you see. Okay, over here, using the same logic from example 1, you are now going to take the whole number part, and that is going to become automatically the minutes in this answer. So 44 minutes, and then you're going to take this part that I am highlighting, and that part is going to help you find the seconds. Okay, so we're going to take the 0.1 right now. You're going to multiply it by 60. Drop a little plus sign here. We got 15 degrees. We have 44 minutes. And then we got 0.1 of 60, and that should be just 6. So there's 6 seconds. 15.735 degrees is the same answer as 15 degrees, 44 minutes, and 6 seconds. Again, make sure that you show like every step so I can make sure that you understand the process. Alright, so once you understand how to go from an angle to degrees, minutes, seconds, now we're going to go in reverse order. We're going to go backwards. Next concept is how do we change an angle from minutes and seconds back to just degrees. Okay, so we're going to go in reverse order. Example 1, 35 degrees, 12 minutes, and 7 seconds. We're going to drop our 35 down. We are going to take the 12 minutes. And recall from the last problem, in order to change that, we had to multiply by 60, since again there's 60 degrees in a 60 minutes in a degree. You're going to do the opposite of multiplying, which is dividing. So now you're going to divide the 12 by 60. You're going to take the number that's in the second position, which is 7, and you're going to divide that by, and we're going to be really careful here because we're trying to convert back to only degrees. There's 60 minutes in 1 degree. There's 60 seconds in 1 minute, but the question now is, how many seconds are in a minute? And so you have to think about it in those terms. I'm going to say that again. We are not looking for how many seconds are in a minute. We're looking for how many seconds are in a degree. And so because of that, we can't just divide by 60. We have to divide by 60 squared. Okay, so be really careful because that tends to throws people off sometimes. It's a common mistake. So we have 35 degrees. Okay, we're going to do 12 divided by 60 on our calculator. That's 1/5, which is 0.2. And just drop that down. And then you're going to divide 7 by 3600. And that is 0.00194. And you notice on your screen right now that the 4s are repeating. You're going to put all three of these values together. So you're going to add 35 plus 0.2 plus 0.00194. When you put all that together, you have 35.20194. And you do need to write all of it, so that way we have a more accurate answer. And then at the end, because we are changing back to degrees, please make sure you remember to put your degree mark on your answer. And we are good to go. Alright, so we're going to try example 2 the same way. Again, we're going back to degrees. I notice my degree, my minute, my second. I drop my degrees down first. Again, that's the easy part. Always put your plus sign next. Then whatever the minutes are in your problem that's given to you, you always divide the minutes by 60. Keep repeating this, but it's important to remember there are 60 minutes in 1 degree. 1 degree is 1/60th of a minute. Then you're going to take the 34 seconds. You're going to divide 34 by how many seconds are in a degree, and that's 3,600, which is 60 squared. So if you prefer to write this, you can. And now it's calculator time. 39 degrees. 5/60ths is the same thing as 1/12. 1 divided by 12 is 0.083, and the 3's repeat, so I'm just going to jot that down. And then you're going to do plus 34 divided by 3600. That's going to be 0.0094. The 4's repeat, so I'm going to stop there. And then I'm going to add all three numbers together. 39 plus 0.083 plus 0.0094 to get my final answer. And don't forget your degree mark. Okay, so last slide, showing you how to go from angles to degrees, minutes, and seconds. And then you also need to know how to go in reverse order, changing from degrees, minutes, seconds, all the way back to just a degree. And you would expect this to be decimal answers most of the time. Alright, next concept is on reference angles. With reference angles, be careful, this is usually confused with coterminal that we looked at earlier. A reference angle keyword here is it has to be an acute angle. Acute means that it has to be less than 90 degrees. So if you are looking for a reference angle and your answer, and you think the answer is 92, it is not. It has to be less than 90 degrees. You're going to find that answer by looking for an angle formed by the terminal side of the angle. That's why I went over that word earlier in the notes, and also the x-axis. So every single word here is super important in order to get these right. To get a reference angle, you have to first remember that the answers are always less than 90 degrees. Secondly, you need to remember it's always formed by the terminal side of the angle that you see and the x-axis. What you see currently on the board are 4 examples. Each of the 4 are angles that are lying in the 4 quadrants, so I can give you a sample of everything that you're going to see. For the first one, you notice that the angle is opening up and only landing in the first quadrant. I'm going to highlight the terminal side in green. According to the definition again, we're looking for the angle formed by the terminal side and the x-axis. And what I should have done before we started is give you the actual angle for that. So we're going to call that 40 degrees right now. Anytime I ask you for a reference angle of an angle in the first quadrant, your answer is going to be the same because that angle is terminal side, which I already highlighted for you, and also the x-axis is equivalent to the given angle. Example 2, notice the terminal side, again highlighting in green, it lands in the second quadrant. I used 120 degrees for this angle, for this example. To find the reference angle for 120 degrees, I have to find the terminal side, find the x-axis, okay, which is close to it, as close as you can get, and this angle that I'm highlighting in yellow is going to be the reference angle. So in this case, it's not the same answer. It's going to be, remember there's 180 degrees in a straight line, in a straight angle, so you're going to subtract 180 minus your angle that you're given, and check out answer here. Answer is definitely less than 90 degrees, so I know that's a good answer. Okay, third scenario. What happens if your angle's terminal side lands in the third quadrant, as in this picture? Notice that I started on the initial side, I swung the angle open counterclockwise. It is 220 degrees. The terminal side's in the third quadrant. I'm looking for the reference angle. Reference angle is formed by the terminal side and the x-axis that's closest to it. It's going to be this angle I've highlighted in yellow. To find that answer, this time, if all of this angle is 220 and I'm only looking for this little piece right here, then I know from what I said earlier, a straight angle has 180 degrees. Then what I can do is take the original angle, 220, and subtract from it 180. So we're looking for the part I've highlighted in red and in yellow, and that answer is going to be 40 degrees. Be careful on this top. I have, from the past, several students make that mistake. So look for that measure. Scenario 4. What happens if the terminal side lands in the fourth quadrant, which is modeled here? Notice the angle starts on the x-axis, it goes all the way around. It is a 300-degree angle. We are looking for the reference. That's going to be this angle marked in yellow. To get the answer, I have to know that a complete rotation is 360. If from here to here is 300, then a really good way to find this is to subtract the complete circle, 360, minus your given angle. So it should just be the leftover part. So that's going to be 60 degrees. Again, notice all 4 answers on the board right now are definitely acute. Alright, next concept is actually coming from section 6.1 in your textbook, and this goes into a measurement that we are probably not as familiar with, and that's called radians. You're used to measuring angles in degrees, but there's other ways to measure angles. Again, that's called a radian. A radian is just, like I said, another unit to measure the angle, and here's what the definition is. 1 radian, which again is new to us, 1 radian is equal to 180 degrees divided by pi. 1 radian is the same as 180 degrees divided by pi. 1 degree is equal to pi divided by 180 degrees. Usually with radians, you have, not always, but usually you'll have a pi in your answer. So very quickly, share this with you. If you have a circle, and let me do this. If you have an angle that starts here, and the terminal side is on top of the x-axis as well, then in degrees, that's 180 degrees. In radians, that's just pi. So what we're going to learn now is how do we convert from degrees, which is something we're comfortable with, to this radians, which is new, and then vice versa. We're going forward and backward. Okay, so look at this circle I've got drawn on the board, and we'll start here. On the x-axis at this location, to be a unit circle, that means that the radius, let me talk this out, the radius is 1 unit, that's why it's called the unit circle. And so at this location, if from the center of the circle to this point is 1, then the location on graph paper should make sense that it's going to be 1, 0. Okay, the location here at the top of the circle, from the center here is still 1 unit long. That's going to be 0, 1. It's just ordered pairs that you've had for your whole math career. And then over here on the left, this distance is still 1. Remember, all radii of the circle in this unit circle is 1. So that means that this ordered pair has to be negative 1, 0. And then the bottom of the unit circle down here, the location is 0, negative 1. Alright, now let's talk about degrees. If we are right here, and the initial side is the same as the terminal side, I have not opened this angle up at all. This is 0 degrees. If I draw the initial side here and swing the angle open, and the terminal side lands right on top of the y-axis, we'll say, then it forms a nice right angle. So at the top of the unit circle, this is 90 degrees. From here all the way, from 1, 0 all the way over to negative 1, 0, that angle is 180 degrees. Next, from here all the way down to the bottom, so from here, grab yellow, from here all the way down to here is going to be 180 plus 90 more. That's going to be 270 degrees. And then if I start in the initial position and I go all the way around the complete unit circle and end up where I started with, that's going to take me 1 rotation around. That's 360 degrees. So 0 degree angle is in the same position as a 360 degree angle. So the reason I'm going over this is to compare it to radians. If I'm at 0 degrees, that's the same thing as 0 pi radians. When I'm at 360 degrees, a complete circle has 360 degrees, but in radian measure, that's the same as 2 pi. So if this is 0 pi, and then all the way around is 2 pi, hopefully it'll make sense that if I start here and go only halfway through, 180 degrees is only half of 2 pi, which is 1 pi. If this is 0 pi, and this is 1 pi, then from here to here is 1/2 of that semicircle. And so at 90 degrees, that's the same thing as pi over 2. 1/2 pi, but we usually write it like I'm showing right now on the board. And then down here at the bottom at 270, if this is pi and this is 2 pi, Then from here to here is 1.5 pi. We tend not to write mixed numbers though. We're gonna call it 3 pi over 2. Alright, so 0 is 0 pi. 90 degrees is the same as pi over 2. That's the radian mode. 180 degrees is the same as pi radians. 270 degrees is the same as 3 pi over 2. And 360 degrees is the same thing as 2 pi. How do I convert? Last concept. How do I convert from degrees to radians? Okay, so let's start with 25 degrees. If I want to write it in radian mode, then I have to use my notes. I have to go back. 1 radian is 180 over pi. 1 degree is pi over 180. I have a degree right now, so what I need to do is multiply by pi over 180. So anytime I'm trying to change from degree mode to radian mode, this fraction is what you'll multiply by every single time. And what the best way to do it in your calculator is to just worry about the numbers, like divide 25 by 180, for example. And don't give me a decimal answer, I need a fraction answer. So change it back. If you're using a TI-84 at home or on your phone, just do math, fraction, which is math 1, enter. You'll get 536. So make sure you know how to reduce your fractions. And then you'll have pi left. And I would prefer that you write the pi beside the number on top. So like 5 pi over 36. That's usually how you'll see it in TRIG. And that's your value. Okay, we'll try one more of those. If I give you, let's say, 215 degrees, in order to change to radians, again, you multiply by pi over 180. You're going to use your calculator and divide 215 by 180. You're going to convert it back to a fraction, which is 43 over 36. That's the best answer. And then don't forget, your pi has to stay in your answer. Backtrack for 1 second. When I'm talking about a pi for radians, remember pi is equal to 3.14 approximately. And I know you know the part of the rest of it as well, but 3.14. So the reason I'm bringing this up is sometimes they don't put pi in your answer. So if they tell you that they're thinking of an angle that has 3 radians, then you need to be wise enough to know that they're talking about an angle that goes from the initial side all the way over to almost the x-axis. So something like that, for example. Okay. So this would be 3 radians. Another general rule of thumb is make sure that when you're writing degrees, like if you intend it to be 3 degrees, you better put the degree mark at the top. Writing 3 degrees and just writing 3 are totally different angles. 3 degrees is super small. It's over here in the first quadrant. 3 without a degree mark means it's radians, and that's going to be this angle that I've shown. So a huge difference between these. This is radian mode when I don't see a degree mark, and this is degrees, obviously, because of the mark. So the whole point in me saying that is make sure you write your degree mark when you're talking about those. And then we're going to go backwards and write it in degree mode. Alright, so let's try this. What about 3 pi over 4. Now, I know that's radian mode because I see a big pi in my problem, and I'm trying to change it to just degree mode. Let's go back for a minute. So to change, let me just type it here. To change from radians to degrees, you need to multiply by 180 divided by pi. Okay, and so let me grab my mark for degree. This is the general rule for changing from radians to degrees. Multiply by 180 over pi. We're going to put that right here. And the way I remember it, I'm trying to get rid of pi if I'm trying to give a degree answer. The only way I'm going to get rid of pi is to have one on top of the fraction and one on the bottom. These are going to cancel for me, and that's what I want to happen. So that's how I remember 180 over pi for this one. You're going to go straight across when you multiply fractions. We know that from the past. So 180 times 3 is 540. And then you're going to divide that by 4, since the pi is canceled nicely for me. And I'm going to get 135 left. Well, that's 135 degrees. Okay. All right, question 2. Let's do 11 pi over 6. Let's convert that to degree measure. Again, the easy way to do this is multiply a radian problem by 180 over pi. Please put the pi on the bottom of your fraction so that way they can cancel. Pi on top and pi on the bottom will just be 1. And then you're just going to go straight across. 11 times 180 is 1980, sorry, 1980. And you're going to divide that by 6. And so that answer is 330 degrees. Alright. Over on this slide, I want you to backtrack for a second because I did not write this down, and I should have. When you're trying to change into radian mode, multiply by pi divided by 180 degrees. Okay, so this you're just going to have to make sure you memorize because we're going to be using degrees and radians forward and backward for the rest of the year. Alright, it is a long section, a lot of learning targets there, so you make sure that you understand the highlights. And we'll continue working on this for a couple days. Okay? Alright, section 5.1 and 6.1.